This is lesson 2-6, Connecting Proportional Relationships and Slope, and it starts on page 128. Example 1 is on page 128. It says Maya and her father are building a treehouse. The roof will have a 9 to 12 pitch, that is, for every 12 inches of horizontal distance, the roof rises 9 inches. How can Maya determine the height of the roof at its peak? So first you can always make a table. So here we have the vertical distance as the top row, the horizontal distance as your bottom row. When you divide, you're going to notice that you have the same answer every time. Now last year, that was called your constant of proportionality. And we did that by always taking the change in y over the change in x. So technically, the change in y, if I was graphing it, would be your up and down number. And if you look, there it is. It's called a rise. And your x number is your side-to-side number. There it is, and it's called a run. So now that we are in slope, we're going to think about rise over run. This continues to be example number 1 on page 128. And all they did was they took their table and they created ordered pairs. So they went over 12 and up 9 and they put a dot. They went over 24 and up 18 and they put a dot. They went over 36 and up 27, they put a dot. They went over 60 and up 45, they put a dot. And then they connected their dots. Now again, a review from last year, I know that this is proportional, not only because the table divided out to the same answer every time, but because when you look at this graph, it's got 2 criteria that make it proportional. One is it's a straight line, and second, it goes through something called the origin, which is this 0, 0. So if you remember the last slide, we had slope, and I was talking about something called rise over run. I'm not a real fan of how they're showing that on this graph because it almost appears that they're running first and then rising. I think if I was doing this book, I probably would go up, up, and then over to show rise first and then run. Ultimately, it doesn't make any difference other than you have to remember you're going up and down first and then side to side. But if you remember, we had a question to answer, and that was, how can Maya determine the height of the roof at its peak? And the roof was 6 feet across to the peak. So we can use this graph to go ahead and figure out that it's going to be 54 inches. So, again, I don't think your book does the greatest job here because we need the length to go all the way to 72 inches, which would be about right here. And then we could follow it up and then over to 54. But it's not super clear. I think I probably would have changed the graph just a hair to make it more clear for us to understand how the 54 was obtained. This is the try it on page 128. It says Jack graphs how far he plans to bike over a 3-day charity ride. Find the slope of the line. Now remember, we're going up first and then we're going over. So I'm not a fan really of how they're doing this because that looks like they're doing it backwards. So I'm going to go up first. I'm going to go from 60 up to 90. 60 to 90 is a 30-mile difference. And then I'm going to go from 2 to 3. That is in 1 day. 30 divided by 1 is 30. That is the slope of the line. It means he's going to plan to bike 30 miles every day. This is example number 2 on page 129. You can also find slope from 2 points. So if I were to give you 2 ordered pairs, let's say, you could do this without the graph. But we have a graph here. It represents the depth of a diving submarine over time. At what speed is the submarine descending? So if we didn't have a graph, we would find this spot right here, which is 5, negative 400. And they're using this dot, which is 10, negative 800. And if you remember, we want the difference in the y values on top and the difference on the x values on the bottom. Just a really fast reminder, your first coordinate is your x, your second coordinate is your y. Now they went ahead and they did that for you, and they found the slope of the line is negative 80. But could I give you an alternative? I think sometimes the best point to start with is the origin, which is 0, 0. It just sometimes makes things a little bit easier. For one thing, it forces you to count on the intervals, not on the lines. Now let's just see what happens if I were to use 0, 0. I'm going to use 0, 0, and I'm this first one. So I'm going to subtract my y's, y minus negative 400 on top. My x's, 0 minus 5 on the bottom. 0 minus negative 400 is 400. 0 minus 5 is negative 5. And I would still get negative 80 because it doesn't matter which 2 dots on the line you use, your slope will remain consistent throughout the entire line. This is example number 3 on page 129. The graph shows the distance a car travels over time. Find the slope of the line. What does it mean in the problem situation? So they just did something similar to what they did in example number 2, but they're going to add some labels. Now they chose to do these 2 dots, and there's nothing wrong with those 2 dots. But I like to use the origin, so I'm going to use the origin and this dot, these 2. And I'm going to go from 0, 0 to this dot. So I'm going to subtract my y's on top. And it doesn't matter which order I start with. I could have totally started this way. Let's see what happens if I do it that way. And 0 minus 2 here, or 2 minus 0 there. This one is going to be negative 110 over negative 2, which is 55. And this one will be 110 over 2, which is also 55. So it doesn't matter if you go this way to subtract or you go that way to subtract. There's a lot of things that don't matter, particularly in slope. But on this example, they wanted us to say, what does this actually mean? And so they're asking for some labels. And what it means is that we have 55 miles every hour. All right, this is the try it on the bottom of page 129. It says the graph shows the proportions of red and blue food coloring that Taylor mixes to make purple frosting. What is the slope of the line? And tell what it means in this problem situation. So we have 2 questions here. We're going to find the slope, and then we're going to add some labels. All right, now I could totally use their dots, but I'm not going to. I'm going to use 0, 0 and 25, 35. All right, I'm going to count up to 35. That's my rise. I'm going to count over to 25. That's my run. I'm going to simplify that by dividing both of those by 5. So my slope is 7/5. But 7 what? And 5 what? Well, it's going to be 7 red because remember I did up and down first, and 5 blue, because remember I did blue, or I did side by side second. So my answer is 7 red and 5 blue. This is your key concept on page 130. It says slope measures the steepness of a line. It represents the ratio of the rise to the run between 2 points on the line. It is proportional, so that means that the slope is the same as the unit rate. It's also the same as your constant of proportionality. Now there's a couple ways to find it if you have a graph. The first one is you can simply count. Find 2 dots you want to use. I'm going to use this one and this one. I'm going to count up to 15 and I'm going to count over to 1. So if you have a graph, you can just use the counting method. If I were to give you ordered pairs, maybe I want to use 0, 0 and 345. You're going to subtract your x values first, any order. Subtract your y values second. Negative 45 over negative 3 is still 15. So you have 2 options for how to find the slope of our graph.